Okay, so welcome back to this lesson. So we're going to try to solve problems on the things we have done, right? The link to the questions would be dropped in the description below. So we're looking at just 4 questions today, all right? So question 1, what is the magnitude of the acceleration of a sprinter running at 10 meters per second when rounding a turn of radius 25 meters? Okay, so if we look at the things we're given, okay, and what we're to find, we'll see we have velocity at 10 meters per second and we have radius at 25 meters, and we're asked to find the magnitude of the acceleration. Okay, so we know that centripetal acceleration is equal to velocity squared over radius. So of course this guy is trying to round the corner, so he's going to be experiencing centripetal force, and therefore there's going to be centripetal acceleration. So putting our values into this expression, we're going to have 10 meters squared, we're going to have 10 meters per second squared divided by 25 meters, which will give us 4 meters per second squared as our answer. Okay, so that was an easy one. Okay, so a metal block of mass 5 kg lies on a rough horizontal platform. If the horizontal force of 8 newtons applied to the block through its center of mass just slides the block on the platform, then the coefficient of limiting friction between the block and platform is, alright, but to find the coefficient of limiting friction between block and platform. So the values we're given are mass 5 kilogram, we have force 8 newtons, and we have to find the coefficient of limiting friction. Now it's very important that we bring out our values like this. It helps us envisage what is expected of us, and also helps us quickly pick what formulas we are supposed to use to solve this problem. Okay, so we know that the coefficient of friction is equal to force over r, or force is equal to coefficient of friction times r. We have the free body diagram here. Okay, we have the normal reaction acting upwards opposite the mass, okay, which is 5 kilogram, and then we have the frictional force acting opposite the actual force applied on the block, which is 8 newtons. Okay, so we have the coefficient of limiting friction equal to force over normal reaction, r. Okay, remember the formula, F equal to mu times r. Okay, where of course we know mu is the coefficient of friction, we know F is force, we know r is normal reaction. So if we look at this, free body diagram, we don't have r. Okay, of course we're not giving the value for r, but we do remember from the class that r is equal and opposite the weight of this, okay, this body, because r is the opposite and equal reaction that is experienced by the action of the weight of this body, okay, on this platform. So once we know that, we realize that r is going to be equal to 5 times gravity. So we have our force to be 8 newtons, and then we have our r to be 5 kg times 10 meters per second squared. So once we do that, we're going to get our coefficient of limiting friction, which is 8 divided by 50 and 0.16. okay, it's a dimensionless constant, so we have no dimension for it. So that's the answer we get for this question. Okay, so for the third one, we have a crate of mass m equal to 100 kg is pushed at a constant speed up a frictionless ramp by a horizontal force F. What are the magnitudes of A, F, and B, the force on the crate from the ramp? Okay, we have theta as 30 degrees. Okay, so if we look at the free body diagram here, you see that we have the ramp, and then we have the crate with the force applied in the horizontal direction. Okay, so the force F is applied in horizontal direction, and we're asked to find what this force F is, and B, the force on the crate from the ramp. That's the force this ramp exerts on the crate. So which means we're looking for the normal force on this crate. Okay, let's take a look at this free body diagram here. So if we do so, we'll see that we have F, of course, in the horizontal direction, and we have mg in the vertical direction. But then we need to find the components of these forces, okay, that this crate experiences. And then since these are the only two forces acting on the crate from the question we're given, when we find these two components, okay, we subtract them from themselves. They will give us the force with which this body moves, okay, because we have F cos theta, which is the experienced applied force, okay, in this direction. Then we have mg sin theta, which is the experienced force from the weight acting in this direction, opposing the force trying to move it upwards. So if we subtract both of them, we will find the force with which this guy moves upwards. Okay, so we have F cos theta minus mg sin theta equal to ma. Okay, F cos theta comes from the fact that we need the horizontal component of this F force. Okay, so the angle F makes with the x-axis is obviously theta. So we get F cos theta for this horizontal force. Okay, while for mg, we're looking for the horizontal effect of mg on this body. So since it's the horizontal effect we're looking for, we can do mg cos alpha. If alpha is the angle mg makes with the x-axis, that's this place. If that is alpha, let's call that alpha. If that is alpha, then we can do mg, we can have mg cos alpha, or we have mg sin theta, okay, where theta is the angle mg makes with the y-axis. Okay, so is either we're doing mg cos alpha to get the x component, the horizontal component of mg, or remember alpha is the angle mg makes with the x-axis, or we're doing mg sin theta, which is the angle mg makes with the y-axis. Right, do we get that? So in this case, we're taking mg sin theta. Okay, so we have mg as 100 kg times 10 meters per second squared, which will give us 1000 sin 30. So we'll have mg to be 100 kilograms times 10 meters per second squared. Okay, and then this whole expression equal to 0 because our acceleration is 0. Remember, it's pushed at a constant speed, so there's no acceleration. So m times acceleration, which is 0, is 0. So we take one of these to the other side and make f the subject of formula. So we have f equal to 1000 sin 30 all over cos 30. So if we go back to what I said here, this can either be cos alpha or sin theta. Okay, so if theta is 30 degrees, alpha is obviously going to be 60 degrees because this is a 90 degrees angle. So if we check, we'll find out that sin 30 and cos 60 have same value of 0.5. So whichever one you use, you'll still get the same answer, but just make sure you don't mix them up. Okay, now since we have this, if we simplify this, we're going to be getting 577 newtons. Okay, so from the part B of this question, it's asking us to find the force on the crate from the ramp. Okay, so that is obviously the normal reaction this crate experiences from the surface of this ramp. Now, if we look at this free body diagram carefully, we see we have just two forces in action, F and mg. Okay, so and both of them are acting at an angle. All right, so we're going to find the components of these two forces, okay, in the vertical direction. So we know that every force this crate exerts on this surface, okay, the surface would give back to it as a reaction. Okay, and that is what our normal reaction actually stands for. The normal reaction is normal to this surface, which means it's perpendicular to this surface. So if we find the force acting opposite this surface, like perpendicular to this surface in the opposite direction, then we have found our normal reaction. All right, so to do this, we have to find the vertical component of force F. And how do we find the vertical component of force F? We find it by F sin theta, okay, where theta is the angle it makes with the x-axis. So we have F sin theta. Now, to find that of mg, we can do mg sin an angle, but that angle has to be the angle it makes with the x-axis. So it means we have to find this angle here, which we had called alpha. But then since we already have theta, why don't we just use theta and we do mg cos theta to get our answer? So let me just solve that here. So for B, what we're going to be having will be our F normal, that's the normal force F, is going to be equal to F, the vertical component of our F force, plus the vertical component of our weight. Okay, all right, so we have FV, F weight. Okay, I just use this to represent FV to represent the vertical component of force F. Okay, why FW represents the vertical component of the weight. Okay, so you can also represent our weight as WV. So we know that yes, it's the vertical component of our weight. So if we do this, it means we're going to be having F sine theta. Okay, F sine theta plus, all right, mg cos theta. Okay, this is cos, mg cos theta. So if we do this, we're going to have we have our F as 577. So this is 577 times sine 30, which is 0.5. Okay, sine 30 is 0.5. Then we add that to mg, which is 1000, if I'm not mistaken. Yes, 100 kilograms times 10. Okay, so we have that as 1000 newtons. 1000 newtons. Okay, I'm trying to get the bracket there, so let me put 1 here. 1000 newtons times cos theta, which is 0.8. So you can take it at 0.87. So if we solve that, okay, we're going to be having a normal force to be 1154, okay, that's 0.5 newtons. So this is what we're going to get as our answer. You can try solving this on your own to see what you're going to get. Okay, so to solve this question, we just have to remember that centripetal force is equal to mv squared over r. All right, so we're asked to find the angular velocity. So we know that linear velocity is equal to radius times the angular velocity. All right, so we have m in brackets rho omega squared all over r. Okay, so if we make omega squared, that's the angular velocity, the subscript formula, we'll be having centripetal force times radius all over m times radius squared. If we find square root of both sides, of course, we're going to have roots fc all over mr. Okay, because of course, one arrow takes out one down there. They're dividing themselves. So this is what we finally have as our angular velocity. If we bring in our variable, if we bring in the values of these functions we've been given, we weren't given fc, so we can find fc by mass times the centripetal acceleration, which is 0.5 kg times 9 meters per second squared. That would give us 4.5. Bringing that into this equation, we have 4.5 divided by 0.5 times 0.25. So if we simplify all that, we have 6 radians per second as our angular velocity.